All right, everybody, we're going to go ahead and get started. My name is Len Thompson. I'm the Community Manager for the Workload Automation community, and we are joined today by Lee Roberson, who is on the line now. Lee, just so you know, you're not sharing your screen yet. That might be intentional, but I want to let you know. For those of you who are not on the phone line, if you have any questions along the way, please use the Q&A box in the WebEx. If you don't see a Q&A box in the lower right of your screen, that's because it is not open. Go ahead and click the question mark icon in the upper right, and the Q&A box will open for you. So with that, Lee, take it away.
Great, thank you, Len. So yes, thank you. Let me share my screen here, and we will get started here. Okay, so hopefully you guys are seeing my slide deck now here. So thank you all for joining us for the next in our series of CA Workload Automation Tech Talks. On this one, we're going to reach into some of the plugins and specifically focus in on how you can leverage the Informatica and database agents to extend the reach of your workload automation solution. So that's really going to be the focus of this. Much of what we're going to cover today will be applicable to all four of the strategic CA workload automation engines. So that would be Autosys, AE, DE, D-Series, ESP, and 7. I am going to provide a small demo towards the end of the presentation that will be focused from a D-Series perspective. But along the way, I'll do my best to point out any slight differences or nuances in these job types and agents when used with particular engines. But the idea is this one's going to be fairly high-level, broad strokes on the job types that each of these agents exposes, and some commentary on different scenarios and use cases where they make a lot of sense to leverage. So again, we're going to talk briefly about the challenges and just how CA views its role in providing specific plugins or connectors or integrations with various technologies, and sort of how that fits into our overall product development roadmap and methodology. We're going to drill into what are the capabilities of each of these agents, so the job types that are associated with the agent for databases, what databases we support. We're going to then go into details around the agent for Informatica, being able to integrate and schedule workflows defined within Informatica Power Center. I'll talk a little bit about implementation, although this session is not going to get into all the nuance and details of all the configuration options in the installation, but we'll cover that at a high level, and then really just show you some sample applications and job types that run these various job types exposed by these two agents. So jumping right into this, some of the challenges that we're trying to address with these types of integrations and agents is this challenge that's always been there and may always be with this, but this idea that, you know, oftentimes you end up with scheduling silos, right? If it's in the database world, you often see customers or DBAs are using native database tools, like Oracle Enterprise Manager or various utilities, command line interfaces. You often see the challenge with that is that you're using different schedulers to manage both your traditional jobs as well as Informatica and potentially all of your database workloads. So the challenge is your lack of that centralized monitoring and management, right? How do you visualize how a database job or a set of Informatica ETL processes fit into a bigger end-to-end business process or workflow, right? And then typically when you're integrating, before we implemented these agents and job types, you were typically writing scripts, right? And you were using various scripting, batch or shell scripting, calling various native command line utilities exposed by the different applications and databases. And oftentimes the result from an operational standpoint is limited visibility into what that script does, right? If you're an operator trying to troubleshoot why did this job fail, or exactly what does this job do within the bigger context of this business process that I'm monitoring. So those are some of the challenges that we're trying to address with these agents. Other things around, issues with, well, if you're scheduling something and there's logs being created within that application, does an operator have access to that? If you're running a wrapper script that calls a command line interface, where we may only be able to capture standard out and standard error within the scheduling tool. So again, the idea is, provide the capabilities so that you can visualize the end-to-end business process, and as you're building those processes and creating those touch points, those dependencies between jobs that cross applications or databases or different systems, again, being able to visualize that end-to-end and make it easier to define those discrete units of work and provide that visibility from an operational standpoint into what they're doing. So let's jump right into that. Again, this just talks a little bit about, you know, typically customers have always started their scheduling within, you know, from a traditional batch perspective, right? And that was typically scripts, running scripts. In the case of many of our products, they're called command jobs, or, you know, Unix or NT jobs in some of our tools. But the idea is, you know, why, some say, why would you bother doing anything else? And in our opinion, commands require, you know, writing those scripts require effort. They cost money to maintain, to test, to validate, to maintain on an ongoing basis. And there's a lot of risk involved in that. What if the guy that wrote that script leaves? What if something changes that has a dramatic impact on the way that script executes? So the idea is, and this is really a bigger picture of CA's approach, right, is leveraging our single point of workload management, right, the single interfaces for managing the end-to-end workload processes, provide rich data and message-driven IT workloads, so being a lot more than just a scheduler, right, leveraging real-time dynamic events in the architecture. So one of the things you'll see, a few of the job types we're talking about today with the database agent are the database monitor and database trigger job types, and those are, in a sense, leveraging an event sensing capability of the agent, right, monitoring tables within a database for updates or changes so that you can trigger workload outside of that database stream. And again, our approach is to provide that wide breadth of workload types, right, a full array of different event triggers and sensors, as well as providing key integrations with, if it's technology stacks like web services or Java. We'll talk a little bit about the way the database agent and the Informatica agents work, though, but they're leveraging JDBC and, in the case of Informatica, the Informatica API, so integrating into those worlds in a tighter fashion than simply running a wrapper script that calls a command line interface. So again, you know, we see the advantages to that. Expand this library of predefined job types. These two agents fit into that model. Allow you to reduce coding, testing, and maintenance of various scripts and support. Help you increase the standardization and really just simplify job streams and how you monitor them, right? So someone with no Informatica experience, someone with, you know, no knowledge of what a stored procedure really means inside of a database can simply look at a job type and see basically what that job does, what it's executing in the underlying application or database. So that's really CA's strategy. These are some of the existing integrations that we have today. I won't go through all of those, but, you know, base system agent and then a series of specialized agents, or what we call plugins. So you'll hear me refer to these agents we're talking about today many times as plugins. They do sit on top of and rely on that basic plumbing in terms of the communication between the scheduling engine and the base system agent. And then for these specific job types, they'll be handed off, if you will, to the plugin that's running as part of that base system agent deployment. And we'll talk a little bit about that further as we get into it. But like I said, we're going to focus on the CA Workload Automation agent for databases and the one for Informatica today. So let's start with a high-level overview of what does the database agent provide. Really, it provides 4 additional job types that are exposed through all 4 of our strategic engines. The database monitor, this allows you to monitor a database table for added or deleted rows, and it's really checking for those changes over a polling interval. And we'll talk a little bit more about that as we introduce the trigger one as well. So the database trigger is another monitoring feature, right? Monitoring a database table, but it can monitor for things being added or changed or deleted rows. And it really is it's taking advantage of putting a database trigger on a particular table in the database. So we provide both of these because one is certainly more granular, more accurate way to detect any sort of change to a table, and that would be the database trigger job type. But we are sensitive to the fact that many database administrators may not want you to place triggers on some of their database objects, and so we provide both options. The database agent itself, we've traditionally supported IBM DB2, Microsoft SQL Server, Oracle, and Sybase. We've also, in recent service packs of the agent, released support for PostgreSQL, as well as Teradata databases. But the general premise is this agent is using JDBC drivers to interact and to connect to and drive these job types within the target databases that we can access. A few things down below, just again, kind of hitting on the fact around the differences between the trigger and the monitor. The database trigger really offers a few advantages over the database monitor, right? You can monitor for more conditions. With the trigger job, you can monitor for rows added, deleted, and updated. And then with the database monitor job type, you're really just being able to capture if rows are being added or deleted. And then the other benefit is the database monitor, or the trigger is detecting all changes made to the database, and the database monitor is monitoring for changes only in 10-second intervals. So, the thing to watch out for is a record is inserted and deleted in that same 10-second interval or poll that we're watching for. We may not detect a change using the database monitor. But it really just depends on your use case, which of these sort of monitoring job types will make the most sense. Now we'll come back to, so the other two are not event sensing job types, but they're really, I want to execute a stored procedure, so invoke a procedure or function stored within a database, be able to include criteria for success, be able to, supply any input parameters, get result sets back, and that sort of thing. And then the other one is a basic building block job type that says, allow you to define within a job a snippet of SQL, right? A select statement, an insert, an update, a delete statement, anything that that you might have otherwise had to wrap into a script and make a call to a native database client command line utility to be able to execute that piece of SQL code. And again, I'll show this to you in the demonstration as well as we go. Now, from an Informatica standpoint, again, the concept's very similar to, say, our SAP or our PeopleSoft. I mean, a lot of our agents are designed to be this notion of the manager of managers, right? We aren't replacing the internal scheduling mechanism of Informatica Power Center, but we're allowing you to define a job in our tools that will define how you want to execute the workflow that's defined within Informatica. So give you, the ability to give you visibility in all of the steps or tasks within that Informatica workflow, give you the ability to start and stop or cancel that workflow, give the ability to restart workflow at a particular step in that workflow. And the other big thing is also give you access to, not only are we capturing information in our own spool file for the agent side, but we're also able to retrieve from Informatica some of those key job workflow-related logs that you may want to look at. So again, whether I'm looking at it from the scheduling engine perspective or I'm the Informatica guy looking at the within Power Center's workflow monitor, being able to look at that same information, see the same information about what tasks failed, what do I want to do to restart that process. So again, we don't replace the internal scheduling. You still define your workflows as you would always have done in Informatica. The extra step is just to define a job within Odysys, CA7, ESP or D-Series that would trigger that workflow. Now, there is a caveat I want to make here as well. So you're going to see in the D-Series demo a native Informatica job type. That is, so it's a job type with specific attributes that you fill in the blanks for to define things like the Informatica target, the repository, the workflow name, et cetera. In Odysys and 7 today, those the native job type has not yet been incorporated, but in still allowing you to leverage that agent for those products, we've written a command line interface, a wrapper script really, that will expose the same functionality of the agent that the native job type does, but you just call it differently. So in the case of Odysys, you're calling it's a command job, and in 7 it would be an NT or Unix job that would basically pass the same information, what target repository, target name, workflow name, what user I want to run this as and connect as to trigger it. Those things are just passed as attributes on the command line, but the same functionality is there for all 4 engines. Odysys and 7 do have in their backlogs to implement the native job type, so those should be coming fairly soon. So again, the point of this slide is to really just hit on the fact that these agents are plugins, right? They require you to install a base system agent and then come back along and run our plugin installation process to install the plugin. And we'll, like I said, go into more detail about that. So kind of drilling into some of the use cases, what's the value of using a database trigger, right? So many times a job, without it, you might have a lot of replicated jobs, right? We're always going to be checking for something, and we're going to run that check on a periodic basis. So if you look at how many times people might be doing that in a day, right, you might be running thousands of jobs in a day that are simply trying to validate something that occurred within the database. So the idea is, instead of running those periodic check jobs 1,000 times or more a day, use a file monitor or a database trigger or database monitor, right, to only initiate the jobs when an update occurs. So you're not doing that repetitive checking to see if there's anything to process or data to act on. So the idea is to give that application more of a real-time feel, reduce the number of overall job runs to do those sorts of procedures. And then, of course, initiating stored procedures directly allow them to be easily scheduled based on database updates as well, right? So many times you might implement a database trigger immediately followed by other SQL or stored procedure job types. This also fits in with the Informatica story, right, where oftentimes Informatica is extracting and transforming and loading data from databases, and so there's a lot of these triggers, these event sensors can bridge the gap between how we're integrating these cross-application, cross-system processes. And then again, these are just some examples of database triggers with multiple conditions, right? Again, the idea of eliminating scripts. You get process savings, less frequent jobs that might be checking for database updates, and then, again, triggering conditions, trigger conditions enabled, filtered for certain specific conditions, and we'll talk a little bit more about that. So really, let's jump into the demo. I know these tech talks are designed to be fairly short and concise, so we're going to switch gears here and go into get my start menu back. There we go. So let's start with the database, some samples of the database job types. So what you have here is, again, I'm in Workload Automation DE desktop client, so this is looking at our D-Series product. But again, these job types are very implemented almost identically across the 4 strategic engines. So whether you're talking about Autosys Jill or in CA7 creating those C-lang statements, the concept's the same here. So we'll walk you through a few examples of this. So here's a typical process flow, right, where maybe I've got a combination of non-database and database workloads to perform a series of run through a particular application process. So let's start. I'll show you a database monitor job type. So again, for each of these job types, there's typically a set of basic attributes that are specific to that job type. So here you can see, like any other job, right, I'm defining what's the agent that it's going to run on. This ITWDEDB happens to be an agent, a Windows server configured for the database agent talking to a SQL Server database backend. So you basically, but the concept of this is, okay, who's the database user this job should run as? Typically with our database agent, you're specifying a connect string, a database URL that says, what's the database that I'm going to connect to for this job? There's a configuration in the agent, so there are a number of things that you might set as defaults within the agent, right? This being one of them. You can have this predefined to define where this agent points. In this example, you can see I'm going to monitor a table in the database called stores, and I'm monitoring for both an increase or a decrease. I could even specify increase, decrease, or both, increase or decrease. I could further specify different monitoring conditions, or in the case of D-Series, I might want to set this up as a continuous monitor so that when this condition occurs, I could specify an alert within the D-Series product that I'm going to call. So that way, the trigger might trigger another application to execute every time the condition occurs. And now, one thing that's a little different I'll mention with D-Series in ESP that's not the same in 7 and Autosys is that the database agent, database monitor And the database triggers are also implemented not only at the job definition level as a job object, but also as an event object. So for those of you that don't know D-Series or ESP, the concept is rather than have to run the job to monitor for an event or start that job, I might have the agent set up to trigger kind of a jobless way of monitoring for that event, and then that event is what's going to trigger this entire application flow. So just a little bit of a difference there. So that's another way they've also been implemented here: database monitor, event type, and database trigger event type. So let's talk a little bit about another one, a SQL example, right? Again, a real basic example, right? But the idea is I want to define within a job type a specific select statement. So here you can see here, right, I'm just using the select statement, right? I'm selecting certain columns and fields from two tables. It includes a join here, and I'm getting the result set back. Now, when you define the job, you might say, well, I want to run this SQL statement. Do I want the output to go to the spool log? So this is an example of that, where if you don't specify anything in this output file field, then you'll get the output into the agent spool file for that job execution. I'll show you another example of that where I am specifying a redirection, if you will, to the output file. Now let's show you another example of a SQL of an insert statement. So here a job definition, SQL, still a SQL job type, but my SQL command is actually inserting a record into a particular table. And again, I'm specifying things like database URL. And then for select statements is when you specify the output file, as we've discussed. Now, kind of showing you an example of the database stored procedure. This is a simple example of a stored procedure that I'm calling within SQL Server. So I define the procedure name. I can define things like return, what's the return data type, what's the success criteria. I can parse that result, the result output coming from that stored procedure to determine a success criteria. And then I can also, this is an example of a stored procedure that did not require any input parameters, but let me show you one that actually does require input parameters. So the idea is you can look at a stored procedure and say, okay, does this require certain inputs to pass to it so that it will execute and return a result set. So here's an example, calling a USP get employee manager stored procedure. One of its inputs is a variable called business identity ID, so it wants to provide a value for that. So you define in this parameter statement the name of the parameter. Is it an input parameter or in parameter? Is it an out parameter or even an in-out parameter? So this one happens to be an input parameter. It's an integer data type, and then I'm passing it a value of 50. And I'll run this and kind of give you guys a sense of what this looks like. And then here's another example of a SQL job type where we actually perform a delete command. So again, the idea is very easy to follow, right? Whether I know SQL or databases or not, I can look at these jobs and get a basic understanding of what they're doing at the target application or database. Now let me switch gears also. We'll come back and run these things if we have time, but let me also show you. So let's talk a little about the Informatica. So again, this is in D-Series, so I mentioned the Informatica is a native job type, just like the database job types here are. And then within an Informatica job type, I have to provide a different set of parameters, right? The Informatica target, a repository name, what's the Informatica user, and then typically a folder name. So these are things that are set up when you define workflows within Informatica, right? These are all part of how Informatica is set up. And then I can also select workflow names. Now, one of the features that I like in D-Series is the ability to actually go out and retrieve a list of workflows. So maybe I don't know what workflow name I'm looking for. I just know it's in this Informatica target, this repository name, this Informatica user. So I can go out and basically retrieve a list of defined workflows, right? So I can select that workflow and I can say, okay, well, let me look at this workflow a little bit and say, what's the workflow details? Okay, there's two tasks within it. Here's my workflow ID, and it's got a start task and a command task. It's command type and event raise task. So I can look at the details. I can see what's that workflow object hierarchy within that workflow. So as I'm building my workflow, I can retrieve that key information I need to understand as I build the job from within the tool. Now what I'll do is, for sake of time, we'll show you guys some of these I've already pre-built. So let's see, I'll show you an example here of, so this is an example of, again, I'm calling a workflow name called employee extract. I could go further and actually specify workflow instance, the task name. So again, if I were restarting, maybe I was had a job failure in an active application in D-Series, I might go into that active application, right-click on this job, and actually do reset the definition. And instead of starting at step 1, I may say, well, I really want to come in here and start at a particular task level because maybe I'm recovering from step 7 onwards, those kinds of things. We can support parameter input files, and then there's obviously a lot of settings in the product to determine, in Informatica, you can determine if a task fails, does it fail the workflow or not. So we respect those kind of decisions that might be made in Informatica as well. So let's trigger this application just to give you a sense of some of the log files you can access and the retrieval information that you can get to. So I'm going to trigger this application and just trigger it as a new scheduled event, and I override the scheduling criteria on this thing. And I'm going to trigger that into the monitor view here. So when I get it, should pop in here. There we go. So there's my Informatica application generation, number 17. Let's open this guy up here and look at it. So for sake of demo purposes, I actually had a link in here that I started as a manual hold. So to start these, as you can see, these applications active. I've got 4 of my Informatica jobs that are all in a predecessor wait state. So I'm going to release or complete this link, and then these applications should run. And these are very fast workflows, so they're going to execute pretty quickly. But while they're executing, I can see details about what's happening here in this agent long status field, right? There's my workflow ID, what's my workflow name, what status is running, what task, command, status running. So tell me what's happening in real time. Now, these are going to, again, happen pretty quickly here. I can also look at things like get workflow log, get workflow run details, get workflow status, right? These are sending requests back to Informatica to do some of the same things that I might do in the application itself, right? So I'm looking at native Informatica job logs. So I can see those workflow log details here, starting the execution, et cetera. I can see how individual tasks performed when they ran successfully with these timestamped information. The other thing I can do in here is if I get workflow run details, right, that's going to bring me back details about the individual tasks and the individual run details of those tasks within Informatica. Now let's look at one that we had that failed here. So if I look at that, basically I can troubleshoot that one of my one of my workflow tasks called command failed. And then I can actually retrieve and see what happened to that individual command task, right? And it looks like we were trying to run some sort of a sleep command, an OS level command that didn't complete successfully. So again, the idea is, right, I'm troubleshooting. I don't know Informatica, but I know enough in here to be, if I'm an operator, to come in here and understand, workflow ID, the run ID, the workflow name, the overall status, and it failed. I could restart this by coming in here and say, restart workflow, specify the task, and, basically control how we get back on track here. Now in this example, I'm just going to complete this so we continue down the path here. But you get the idea. And we're also capturing spool output, right? So some of it's a little bit duplicated information, but that way there's a specific agent log associated with every Informatica workflow execution. And again, I'm seeing that same information, right? Execution of command sleep did not complete successfully. And then you can see where our last application job is running. And I get all that rich detail returned back to me in the tool. Now, as far as the, let's show you, again, not that exciting to watch these things run, but I'll show you this database application. So we'll trigger that. Same thing here, I've got a few manual hold steps in here so I can kind of release the application. And then you can see here that my database monitor job type is, right, you can see that he's monitoring, right? He's monitoring stores table for updates, increase or decrease in this case. Here's the database we're connecting to. And then we still have a Windows job executing here. Here I'll show you my the details of the output. This a select statement here. So if I retrieve the file, and this is one where I told it to redirect the output. So you see that message in this pool output redirected to this location. And then this is an example, if I retrieve the spool log, where we let the results of the SQL query get returned to the spool output. So here you can see the results of that SQL query that I executed. And then obviously the benefit of whatever these job types are, right, it's leveraging the features of each of the engines on how these dependencies fit together, right? An insert database jobs dependent on a Windows job, those kinds of things. Now let me release this SQL insert job. So again, that's the basic capabilities here of the agents and the job types, and some of the key use cases we see customers leveraging them for. Now at this point, let me cycle back and just cover a few things in the PowerPoint. We talked about a CLI, so I just wanted to mention that for CA7 and Auditus customers that may be on the call. So the features of that, let me just find a couple of slides here to go over. So again, in the interim, until those two engines incorporate the full native Informatica job type, we've written this wrapper script. So this is where they're located on either Linux or Windows. They're part of the agent install. There's an entire CLI document in DocOps on how to use this thing. But in essence, you're basically providing you're passing a command, referencing the script name, and then passing a set of positional parameters to tell it how to run. But it's the same information you saw in the native job type, right? What's my Informatica target? What's my repository name? What's my command that I'm going to execute? I'll show you that typically you're executing what's called a start workflow command, and then you're specifying things like the folder name and what's my target workflow name. Here's the kind of a list of some of those key commands. Start workflow is the one you're going to use most often, but there are other workflow commands to be able to do some of the same things you saw me do in the desktop client for D-Series. List all workflows, retrieve workflow details, get object hierarchy and workflow, get task details. So these things could also be set up to run, to retrieve information that you want to see through the tool. I've even seen customers use our enterprise command line interface, if you're not a sysshop in WCC, to run some of these commands. But that's really this format of what you're putting into that. Now, before I turn it over to some questions here, I'll just cover a couple of housekeeping things here at the end. So a few announcements. If you want more information on the CA Workload Automation agents, you can see that at our docops.ca.com website. Today we have a Workload Automation Agent 11.3 DocOps site that encapsulates all of the plugin documentation in a single doc set. So you can go in and see, what are the release information requirements for each particular agent? How do I install each particular plugin? That sort of thing. We have the CA Communities website for more information as well. And then, of course, the details on defining each job type within each engine is part of the broader documentation set for each engine. So those are also DocOps links up there for if you're looking at Autosys 7, D-Series, or ESP. And then a couple of plugs for a few more Tech Talk events coming up. There's going to be a series of two, September 13th and the 27th, getting into the details of CA Datacom with CA Workload Automation CA7 Edition R12. And then there's also, for D-Series customers, there's another office hours for live online chat for Workload Automation DE. So if you have any questions you want to ask our experts, you can do that through the live chat event on September 8th. And then what CA meeting or presentation would be remiss, right, not to plug CA World. So CA World's coming up November 14th through the 18th. And it's in Las Vegas again. And one of the things we wanted to highlight from the Workload and mainframe business unit is that we've really beefed up our programming and our education sessions, right? So there's 90+ pre-conference education sessions. There's going to be a lot of coverage on new tech trends, performance analytics with workload automation, things we're doing with our iDash tool. And so that's the dates for that are November 14th through the 18th. So with that, I'll turn it back over, Lynn, to you. And do we have any questions from the audience?
Yeah, there's one question. I'm not sure. Are you able to see the Q&A box? Because I'm not sure I know what this question is, so I'm nervous to try to read it. Are you able to see it, Lee, or no?
Yeah, I'm trying to. Is it chat or is it under another heading?
It's under Q&A. There should be a question mark icon. All right, I can try to read it if you want me to.
I see it. I see it. Okay. I had to minimize what I was in.
Okay. Good.
I see a question about, are you going to share the slides after the presentation? We can certainly make them available. Yeah. And I don't know what our procedure for that is.
Yeah. If you just send it to me afterwards, I'll take care of that.
Okay. Yeah, and you'll see there's some other slides in this deck that might be useful. There's some slides that go into a little more detail on the CLI and some of the screenshots from, in this case, D-Series example.
There's actually a question up above that one.
Yeah, I'm trying to parse that. What does this stand for? DBSP, job type, point of view. Not sure I understand the question from that. Yeah, so the DBSP is definitely the database stored procedure job type. I'm not sure what he's asking, unfortunately. It's from Syed. Hanif Syed. I don't know if he's on there. Maybe he can unmute and we can discuss that one.
Yeah, and if he's still not on, he can always ask the question in the community as well.
Okay.
That's the only other question. So unless he jumps in the next minute or so, we can wrap things up. And just for everyone's information, I will get the replay of this session along with Lee's presentation posted out in the community later today. And Syed has not responded, so I guess we can wrap things up. Lee, thank you very much, and thanks to everyone else for their time today.
Thank you.